Hey folks, in this video, I'll be introducing you to the concept of diamond standards. This concept was created as a part of the Ethereum improvement proposal number 2535, which talks about how you can write or create a structure for upgradable smart contracts. For this particular standard, I will largely be using the actual EIP document itself because it is quite exhaustive and has all the pointers instead of copy pasting all of the pointers on the slide. So the idea, as I mentioned for the diamond standard, is to create modular smart contract systems that can be upgraded or extended after deployment. So right now, if you think of post-deployment upgradation, we are mostly relying on factory contracts, and even factory contracts are actually used to spin up new contracts. However, what if you have interactions that need to be changed from scratch, or your child contracts that need to be changed from scratch, right? That's where the diamond standard will come into picture. The diamond standard or diamonds themselves have virtually no size limit. That's because they themselves do not operate too much with the storage side of things. So, diamond is a contract with external functions that are supplied by contracts called facets. We will look at what are facets and how they play an important role in this standard. But facets themselves are separate independent contracts that can share internal functions, libraries, and state variables. So typically when you are writing a library, your library can actually be used as a facet which provides these functions to your diamond standard contract. Now, of course, there are multiple motivations to use diamonds. One of the top ones being upgradability and extensibility after deployment. But let us look at some of these pointers that they have mentioned here to be able to understand why diamonds are important. Diamond contracts provide a single address for unlimited contract functionality. You can have multiple facets and link them to diamond, a particular diamond contract, and that particular single address will have all the contract functionality, which makes deployment, testing, and integration with other smart contracts, software, and user interfaces easier. Now, what if your main contract exceeds the 24 KB maximum contract size, right? You may want to, then you are trying to find ways to optimize that contract or remove functionality. Instead, if you can have a diamond, it does not have a max contract size. A diamond provides a way to organize contract code and data. Of course, what if you are building a huge dApp which has multiple contracts, it has multiple touch points of interaction. So you want to make sure that you are able to understand the workflow of how you are accessing these contracts, how you are calling the functionality, etc. And this is where a diamond can come into picture, where it provides a systematic way to isolate different functionality and connect them together. A diamond provides a way to upgrade functionality. Of course, this is the pitch that we started with, right? That if we want upgradable smart contracts, then upgradable diamonds can be used to add, remove, or replace some functionality. Because they have no max contract size, there is no limit to the amount of functionality that can be added to the diamonds. A diamond can be immutable. It is possible to deploy an immutable diamond to make an upgradable diamond immutable at a later point in time as well. So it's not a restriction that it is always, upgradable. A diamond can reuse the deployed contracts. So instead of deploying new contracts to the blockchain, you can use the existing deployed contracts, which for me personally, I feel is one of the biggest perks of having diamonds, because on-chain contracts themselves can be used to create diamonds. So this enables the creation of on-chain contract platforms and libraries, right? You can also check EIP 1538 because this standard is an improvement of 1538. Let's take a quick look at at what are facets and how they are used by diamonds. So facets are used by diamonds for accessing certain functionality. Now you can see in this particular piece of diagram that we have two facets, facet A and facet B, which in itself has some pieces of code. Now the diamond 1 uses both facet A and facet B for accessing certain pieces of data, and it's the same with diamond 2, which accesses both code A, that is facet A, and facet B to use some piece of data from there as well. So this is how you can imagine that there are facets that are written, and then diamonds use these facets to be able to access the data and perform the functionality that is requested by the user. In this video, we will stop over here because this is largely the main thing that I sort of wanted to introduce, the introduction to diamonds, the way facets themselves work. In this lesson, of course, we will also be seeing some code about how diamond, a simple basic hard hat code of diamonds, and then how facets are written and how the diamonds are using the facets, etc. Right. So in this video we will stop over here. In the next video we will look at a little bit more detail about the diamond standard, and then fourth we will look at some piece of code to understand how this is written. Thank you, and I'll see you in the next video.